Welcome to this video. So in this video, we'll be looking at double integration questions that involve polar coordinates. Okay, so the interesting thing about polar coordinates is that it makes our integrals very easy. All right, so let's read the question. So they're saying for each of the following integrals, do the following. Okay, 1, sketch the region of integration, and then 2, evaluate the double integral. Okay, so we'll start with A there. All right, so the way A has been given there, it means that our region of integration, okay, it will be r comma theta such that, okay, r comma theta such that my r, the inside integral here, my r is from 4 to 6. So this is 4 to 6, okay? And then my theta is from what? Pi all the way to 2 pi. So this is my region here. So how can I sketch this region? Okay, how can I sketch this region? So let's draw our axes. Okay, so we're sketching in polar coordinates. So it means this line here is just the 0 or the 2 pi. This one is the pi over 2. This one is the pi. And then the one down here is the 3 pi over 2. Okay, and then there, of course, we can have our 0. Okay, so our region states that the theta should be between pi and 2 pi. So this is pi and this is 2 pi there. So it means our region here will be somewhere below here. Okay, our region will be below somewhere there. Okay, so what do? We sketch it. Okay, so now how do we sketch it? Since we know we have been guided by the pi, okay, I mean by the theta. Okay, we've been guided by this theta that our region should be below there. Okay, because it's between pi and 2 pi. So now we go to our r. So they're saying r is from 4 to r is equals to what? 6. So r is the radius. So simply meaning that this is a circle with radius 4. And this is a circle of radius what? 6. Okay, but now we'll only consider the part of the circle that goes below here, because that's where the theta is. Okay, so I can say this is minus 4, this is 4, and then I have minus 4 somewhere there. Okay, so it means if I have another 4 there, if I draw the full circle for r is equals to 4, it will be this circle. Okay, but now I'm not considering this upper part here because my theta is from from pi to 2 pi. So I'll only consider the part below. Okay, so it means I'll only consider this part like that. Okay, so from the origin to anywhere on this curve here, my r is equals to 4. And then I also do the one for 6 like that. Okay, so even for the one for 6, there will be 6 there, and then I'll draw this circle here. But I'm not considering this part on top here. Why? Because my theta is from pi to 2 pi. So I'll only consider the part that is down. So I'll just consider this part here. Okay, so it means the region of integration that we are looking for is actually this part here. Okay, so this is our r. All right, so we've sketched our r. We can now evaluate our integral. Okay, so you don't have to change anything on the limits when you're evaluating this one. It's already given in perfect form, so just evaluate it. Okay, the only thing that we wanted to do with the region is to see where it is. All right, so let's sketch this one. I mean, let's evaluate. So I'm going to say the integral, okay, 2 pi to 2 pi, and then I can evaluate the one inside there. So I'm going to get r squared, and then over 2, and then I have 6 to 4, okay, and then d theta. Okay, so from there, what do I get? I get this is equals to pi, 2 pi, and then this one I'll just substitute. So if I substitute 6 here, I'm going to get 36 over 2 minus, if I substitute 4, I'm going to get 16 over 2 d theta. So this is just going to be equals to pi to 2 pi. Okay, so this here, 36 divided by 2 gives me 18, minus 16 divided by 2 gives me 8. So I have 10 d theta. So when I integrate 10 with respect to theta, I get 10 theta, and then the limits are 2 pi to pi. So this will just simply mean that I have 10 multiplied by 2 pi minus 10 multiplied by pi. So this will give me 20 pi minus 10 pi. Okay, so this means my final answer will just be 10 pi units squared, because we are referring to this as the area. Okay, so that's how we can solve the first one. So now let's look at the second one. Okay, so the second one is a bit interesting than the first one. Okay, so the first one, the second one is this one here. So according to this, it means R is from 0 to 2 theta pi. Okay, R is from 0 to 2 cos theta, and then theta is from 0 to pi over what? Over 2. So it means my region, okay? It means my region, I can write it here, according to this, is that R comma theta is just that, okay? My R is from 0 to 2 cos theta, and then my pi is from 0 to pi over 2. Okay, so that's what we have there. Okay, so we can actually sketch this region here. Okay, but before we sketch it, we need to manipulate some of these, because I can see a trig function there. Okay, this one is straightforward. We know it to be from 0 to pi over 2, but this one we need to manipulate it. So from here I get that my R is equals to 0, well, all the way to R is equals to 2 cos theta. Okay, so I need to manipulate this. I need to know what this is. But it turns out that this is just a circle. But how do you get to that circle? Okay, so we know that in polar coordinate, x is equals to r cos theta, y is equals to r sin theta, and then r squared is equals to x squared plus y squared. So I'm going to say, let my r squared be written in this form. So r squared, let it be r multiplied by r. Okay, and then from here, if I get 0 as my r squared will just be 0. Okay, and then if I get r is equals to 2 cos theta, then I'll have r multiplied by 2 cos theta, okay, which is just 2r cos theta. But now notice something interesting here, okay? We notice that r cos theta is actually x. So where there's r cos theta, there I'll put x. So this means that my r squared is 2x. Okay, so now I can use this equation here. So where there's r squared, I'll put 2x. So it will be y squared plus x squared is equals to 2x. So this will be y squared. This one comes this side. It will be, x squared, and then the 2x comes this side. So it will be minus 2x plus y squared is actually equals to 0. So this one, we can complete the square here. Okay, so once we complete the square there, what we get is simply x minus 1 squared minus 1 plus y squared is equals to 0. So this will give me x minus 1 squared plus y squared is equals to 1. So now we notice that this is actually a circle. Okay, so this is a circle with center being 1, 0, and then r being equals to 1. Okay. All right, so that's what we get there. So it means we can now sketch, okay, because we know that this r is equals to 2 cos theta is actually a circle, okay? So let's sketch it. So that our region of integration, if you show it on a sketch, it will be this one here. Okay, so remember this is 0 to pi. This is pi over 2. This is pi. This is 3 pi over 2. And then this is 0. So this circle has a center at 1, 0. So my 1 can be somewhere there. So let's say that is where my 1 is. Okay, and then my 2 can be somewhere there. I have minus 1, I have 1. So if this is my center and my radius is 1, it means I'll go 1 step to the right, 1 step to the left, 1 step on top, one step down. So it means this will be my circle here. Okay, but now we have to consider the limits for theta. So remember the theta here is from 0 to pi over 2. So this is my 0, then I'm going to pi over 2. So it means I'm only considering this part on top here. That's my region there. Okay, because there, that's my pi over 2. And then here, that's my what? My 0. So that is my theta like that. It's sweeping from 0 all the way to pi over 2. So I'm only considering this region here. I'm not considering this one down, because if I go down, it will mean that I'm sweeping the entire thing here, which is 0 to pi over 2. Okay, but my restriction is just from 0 to pi over what? 2. Okay, so if I get the whole thing, it will be 0 to 2 pi. And then my region demands that I get 0 to pi over 2. No wonder here I'm only shading this top part there. Okay, so that will be our region of integration. Okay, so we are just showing it there. It's not even helping us evaluate this integral. You can still get the answer to this even without sketching here. Okay, because it has been given directly to you. So now let's try to evaluate the same integral that we are evaluating over this region here. Okay, so I'm going to say my integral is actually equals to 0 to pi over 2. And then I will evaluate the inside integral. So it will be r squared over 2, and then 2 cos theta 0 d theta. Okay, so this means that I have 0 to pi over 2, and then I can put this into there. So that would be 2 cos theta squared over 2. So this will give me 4 cos squared theta over 2. I divide, so I just get 2 cos squared theta. If I put 0 there, to just be 0. So I have d theta. Okay, so this is what I have. So now I can evaluate this integral easily. Okay, so here I'm just going to use a trigonometric substitution, because cos squared theta, okay, I can't integrate it. It's not elementary. So what I'm going to do here, I'm going to say, okay, recall that, okay, from the double angle formulas, recall that if I have cos, okay, A plus B, this is the same as cos A cos B minus sin A sin B. Okay, you can remember this from your first year, right? So now what happens if I have the same angles there? So for example, if I have theta plus theta. So theta plus theta is just 2 theta, right? So I'll follow the same arrangement. So it will be cos theta minus sin theta sin theta. Okay, so meaning that this will just be, since it's cos theta, it will be cos squared theta minus sin squared theta. And then I can change this sin squared theta to a cos. Okay, so cos squared theta minus this sin. Remember, sin squared theta plus cos squared theta is 1. So if I make sin squared theta the subject, I'll have 1 minus cos squared theta. So this will just be cos squared theta minus 1 plus cos squared theta is equals to, okay, this one here is cos 2 theta, of course, is equals to 2 cos squared theta minus 1. So now I want to make this the subject. So it means my 2, okay, I can write it here. My 2 cos squared theta is actually equals to 1 plus cos 2 theta. So I'm going to replace this with this. Okay, so I've shown you where it's coming from here. Not here, where has it come from? We have shown there. Okay, so now let's evaluate this. Okay, so this will be from 0 to pi over 2. And then this one, I will put that one. So 1 plus cos 2 theta d theta. So I can integrate this now. So when I integrate this, just be theta plus, when you integrate cos 2 theta, I'm going to get sine 2 theta. Okay, but there's a function of theta inside this. So I differentiate 2 theta. When I differentiate 2 theta, I get 2. So I divide this one with 2. Okay, and then I can put the limits there. Okay, so it means my integral will just be pi over 2 plus sine. Okay, this is 2 multiplied by pi. 2 multiplied by theta, but theta is pi over 2. So it will be like 2 multiplied by pi over 2 here. So the 2 and the 2 goes, so this will just be sine theta. I mean sine pi divided by 2. Then if I put 0 there, it will just be 0 there. Okay, and then minus, if I put 0 there, it will be sine 0 over 2. So now what is sine 0 and what is sine pi? Sine pi is 0, so this becomes 0. Sine 0 is 0, so this becomes 0. Okay, so the only answer that I remain with is just pi over 2 units squared. Okay, so that is our answer on B. All right, so it means for this question, we are done.